mate. My name's Mark Harris. I look after the Hawle group of companies for Oceania. We're a Austrian business, over 75 years old now. We are the original inventors of the resilience heated gate valve, so it was created by our business many years ago. We also invented the restraint connections, mechanical connections for polyethylene, large diameter clamps for PE. As a business, we also have Nova Serera as part of our business, which is an Italian manufacturer of carbon steel products, coated in plant-based coating, real sand nylon 11 it's called. And we do restraint fittings, which we'll run through some of the advantages of these products a little later. Yep. And we also have Ozcan, our valve manufacturer out of Turkey. We're the most technologically advanced valve factory in the world. Okay. Yep. In Turkey. So there was a lot of investment went into that about 4 years ago. Yep. And for me, I've been in the industry for 34 years. Yep. Across Australia and New Zealand. So have a pretty good knowledge on products and industry. I look after the specifications, approvals, do presentations with Hygrade at water authorities, consultants and engineers, get involved with consultants and water authorities in relation to designing fittings to suit special applications such as Nova Serera fittings. Yep. But our flagship product for Hawle has always been our gate valve. So this is our E3 gate valve. So this is now our new generation of gate valve. We were the originals. We invented the gate valve. We still produce the best gate valve in the world. It's without contention. The difference with an E3 gate valve is that we have 100-year design life. We have 15-year warranty. We have, in some cases, 25-year warranty if we know what the operating conditions are. Yep. Any of our fittings that you see are manufactured from a metal called GGG 415. Okay. And whilst all fittings look blue and they all look the same, they're not made equal. So the material itself, ductility is the 15. Yep. Most ductility in fittings you'll get in the market today is 7. And why that's important is because any movement, any seismic activity, anything like that affects the flanging. Yep. And also the bodies on fittings and valves. The more ductility there is, the more flexibility there is in the fitting to deal with any kind of movement. So it's the hardest material to try and cast, which makes it expensive. The other features for our product is a duplex stainless steel spindle rather than a 316 stainless steel spindle. Yep. What that means, more corrosion resistant, it's more wear resistant. We use cold rolled rod to produce our spindles and to thread our spindles rather than casting spindles, which makes them stronger and gives them a lower torque. So in any valve, the torque is always an issue. Our valves are around about half the torque of our competitors in the market. Yep. So they're so much easier to operate. So I mean, if you get on, you get onto this one here, and you can turn that with your hand. Yep. You can't do that with most other valves. Yep.
We'll find a loose valve in the ground.
That's right. And we've had instances of valves 50 plus years old, never been maintained in Austria, and something's happened in the network. The first thing everybody thinks is, can I shut the valve off? Because they didn't even really realise they had one there. Yep. They get there and the valve operates at the same torque that it was installed with, and that's the quality difference. So our slogan is made for generations. It's what used to happen. Yeah. Previous to 30 years ago, everything was made to last generations. Now things are made to last months, years.
Months, yeah. We've heard about some hot water services.
Yeah. So, across all industry, I guess, when you start adding in products that aren't, you have no traceability for, they're using cheaper metals, and the quality of the people putting it together and the technology that's involved in that, there's going to be issues. And when I say months, some of them obviously have issues immediately, some of them have issues 5 years down the track. And our valves are probably, they're more expensive than anything else in the market. But the big difference is people selling them never have to deal with complaints about them failing. So they go in, they stay in, they operate, they never have any problems. They don't cause injury because when you operate them, they operate easily. Your DN600 valve, for instance, can be operated with a hand wheel with one finger. Under full pressure, full upstream pressure and zero downstream pressure, no bypasses, no gearboxes, nothing. So it's a huge difference. And then you talk about reputation. Contractor putting in a valve in the ground and it fails in 2 years. It's his reputation because he's got to then go back to the council, or the council take it over after 2 years, and it becomes their asset, and then all of a sudden 6 months into the new asset it fails. They have to repair it. In most cases, councils don't repair them. They'll go out in the middle of the night, they'll take it out, they'll put a new one in. Quite likely the one that they took out they put in, and they just replace a problem with another problem. And it's not necessarily their fault at that maintenance end, because in the middle of the night they don't want to be shagging around, taking off bonnets and all that sort of thing. So, but at the front end of councils and when tenders are put out, they should be putting them out for how long they want. And a big thing too is when you start talking about 100-year design life. It's a big topic at the moment. Polyethylene systems have a 100-year design life. And then they're putting in, as soon as they put in a valve that has a design life of 10 years, the whole system has a design life of 10 years.
Oh, really? Okay.
So, because if that fails and they have to shut the water down and take it out, then it's no longer a design system that lasts 100 years. So,
so how do you get to that point where you can say confidently it's a like what type of testing procedures does it go through to get to that point where you go, hey, it's got 100-year lifetime basically?
Well, we've been making these for over 60 years. And we've got them in the ground. We've done tests on them. We've checked the torques. We've checked the quality of the coating. We've done all the necessary tests so we can extrapolate that out to 100 years. But also, it goes through 10,000 open and closed cycles as a test every so often. We test our valves, pressure test them, but we also batch test the coating. So the coating system is a Blue Shield. It's a Scanobel coating or GSK coating. It's
what does that mean?
It's just one of the best. It's the best kind of paint coating there is. So it's the fittings are heated up and then the fittings are sprayed with a powder, and then the powder adheres to the body of the fitting. But before it gets to that, the fitting goes through a sandblasting process. It's then coated with a clear coating, which is an anti-corrosive coating. Then the coating's put over the top of that. So that if there was a damage on the edge of any of these, you wouldn't get corrosion continuing past that. It would stop at the point of damage. So that's why you get a long-lasting valve.
Hence why it's so thick as well.
Exactly. So 400 in the material, 400 means MPa strength. But because 507 has 500 MPa strength, we add extra metal. The ASNZ standard says minimum 400. We add extra metal to make it thicker to give it that strength, and in the larger sizes we add ribs to add extra strength to the MPa side of it as well. But then you get the added advantage of ductility. So as a valve, this is by far the market leader. Hawle are a company, as a business, over all of our businesses, we manufacture from 100% European parts and materials and 100% in Europe. We're the only global company doing that now. We have a very close competitor that does a similar thing in Europe, but then for Australia and New Zealand, they bring in product from outside that to compete with the cheaper products, which we don't intend to do, because it's part of our strategy to make sure that we are responsible putting in good quality product into the network.
And do these change in different countries, or are they all?
They're all the same. Yeah, all the same.
Same watermark.
Our standards here are different in relation to the body length, the flange thickness, and the flange drilling, and also our coating thickness as well to everywhere else in the world. So, but apart from that, it's exactly the same valve from one country to another. So we have a flange version. We have a System 2000 version, which is dedicated for polyethylene. The difference here is that obviously you're not having to flange. So wherever there's a flange, it's a leak point. In the standards, you're required to install a flange against a flange, then bolt it up, torque it up, test, and then after testing, you're supposed to re-torque again. Often that doesn't happen because you're busy and things, but any movement over time can create a leak in that connection as well. So, and with a System 2000 connection, it's a plug and play thing. So basically, you're chamfering the pipe. You're giving it a bit of a clean up on the outside. You're putting some lube on it and putting lube on the gasket just to allow it to get through. You're pushing it in, and then you're just tightening up these bolts. The big advantage with the System 2000 is no torque wrenches. So there's plastic washers in the body. What they do, there's two functions. One is to protect the internal body coating from the bolt, stop it from damaging, and then you've got the other advantage is that once the end of this plastic washer hits the body, it's fully installed. Doesn't need torquing or anything else. No thrust blocks required. So it's a completely thrust fitting. So once it's installed, there's nothing else to do. You don't have to pour concrete or do anything else. The only thing you've got to be aware of when using restraint fittings here is that if you have PE coming in here and then downstream you have ductile iron socket spigot, you have to put a concrete thrust block over the first one of those, because otherwise it will pull out because of the expansion and contraction of the PE. So, but made the same way. The System 2000 connections themselves have a 100-year design life, and they are that's NADA accredited third-party 100-year design life testing. So we've gone through the expense and the time of having 100-year design life testing on this, which means 8,000 hours of extreme testing in salty water, hot and cold, hot air, which is always the most corrosive environment. When you've got salt on something and you add hot air to it, it's going to be the most corrosive environment. So again, there are many copies out there of our product, but that's exactly where it ends. But this is the original, and it's still by far the best. And we don't have failures. We never have failures on our products. Millions of products sold and no failures. Generally, the failures happen at construction sites. So when somebody hasn't maybe paid attention to something, then. But we always support the product first to make sure that we get a result that's a positive outcome as well.
And is there, so the System 200, is that more common now as opposed to the table design, or is it sort of varied?
It's still a lot of flanged valves. It's still everybody's preference to go flanged. And
why is that?
And
That's what they used to.
It's just what they're used to,
I like the idea of it being in a fitting.
Yeah.
From a plumbing background, that's all.
Yes,
Yeah.
you know, exactly, and that's a big part of it as well. Is it's just a matter of understanding the reasons why you would use this over that, and getting people to see past cost.
Yep.
And looking at it for the overall reason why. So with a System 2000 connection, it's more expensive than a flange valve.
Yep.
But you've still got to weld a stub flange onto the end of it. Then you've got to add a backing ring. So all of that takes time.
Yep. Plus the bolts head. Bolts are always fucking dirty.
Bolts and washers,
gaskets.
Yeah.
And all the charge out rates for labour are things that get kind of missed in all of this. So if you were to take an overall sort of holistic view of the installation of these products, and you say, okay, then how long is it taking me to install that with a polyethylene system as opposed to this? And labour's quite often one of the most expensive parts of any job. You know, well over $100 charge out rate, and so you add a couple of hours for waiting for welding to go off.
$100 to be nowhere near enough.
No, it's not. But but just being being conservative, you know, conservative. And
no, we've had it before on certain sizes where I've had to go weld it because the guys haven't been able to. So then you take us off it, and then, as I said, bolts.
Just
setting it up.
You need to go and get this. You get that. That's plug and play.
Yeah, exactly.
Moxie's ran out of.
And you guys have got to do test welds, right?
And it might be only a couple of $100 more.
Yeah.
Overall.
If you do a big job, you're going to have to do test welds. So you have to do a test weld, get it approved before you can do the job. Then I can guarantee that in a crew of maybe 3 crews welding, that there's probably a supervisor there that's got their ticket and is able to supervise everything. But when you can't supervise 3 crews doing everything to make sure that with a welding process on EF or something like that, that every step has been followed. And mistakes happen, and you know it's the failure rate not because of the fitting itself, but because of maybe some installation issues or something like that. It's at least 20%. You fail on a connection with EF, you have to cut it out. You have to add more than one coupler, because generally you have to add a piece of pipe because you've had to cut something out. And then you're welding again. You're taking more time.
Plus you got water in the welds.
You know, your trench design's bigger because you need a bigger, cleaner space. You need a calibrated torque wrench. You need somebody who knows how to use it and set it to the correct torque. You also need exclusion zones when you're on site. So on the side of the road, you need a traffic control because you've got generators to run welders. You've got fuel that you've got to have. You've got all of this extra equipment. With a System 2000, you turn up with a wrench. Or a socket wrench of some sort. And there's no torquing. It's on the back of the ute. You can park it on the verge. You probably don't even need traffic control. The trench design's smaller. It's not as deep. It's not as wide. And you plug it in. You test it. You backfill and you're out of there. So it's hugely beneficial. So
when you're talking to the designers, are you trying to push this more in the flange?
We're sort of getting there. But the thing is these days is that they sort of go with whatever the water authorities want, and nobody these days is allowed to specify a brand as such, because it's that's just the way the industry has changed. But definitely the advantages of this over a flange connection, and for future leak proofing, because as we know worldwide that water leaks are a major issue in the whole of the world in relation to water networks.
Are you finding that in production, producing more of these rather than flanges?
We're producing more of these for this market because the flange valves are just are too expensive for the market. We still sell a lot of these, but nowhere near as many as the other options in the market that are cheaper versions. So it becomes a bit of an economy thing, I guess, is upfront cost versus how long you want it to last for. So there's a little bit of a disconnect there. But the big thing is these guys from Hygrade and TradeLink and stuff, they install get one of their customers to install one of our products, never get callbacks for issues. Phone calls at 10 o'clock at night saying we need another valve because the one you gave us doesn't work. All of those sorts of things that cost extra money and pain and stress and everything else. So there's a lot of things outside of the actual cost of the product itself. Okay, so we just talked about System 2000 valves. All of our fittings are also 100-year design life. We have this sticker on here now, which is an official sticker. It's not a test that we've done internally. It's a third-party 100-year design life test. Why that's important is everybody wants a polyethylene system that is 100 years. And at the moment they're installing products that aren't 100-year design life, and that takes away from that whole thing. It's ridiculous, actually. So, and in some cases, with the fail rate, and like we explained over there with the valve, it's the same thing with the flange adapter, for instance, System 2000 flange adapter. The big advantage here is obviously you're bolting this to your fitting or your valve. You're pushing in your pipe and you're doing up 4 bolts, no torque wrenches. It's not too heavy, and it's installed in like 8 minutes, as opposed to 2 hours for, say, welding something. By the time you wait for it to cool, or depending on conditions outside, if it's dusty, if it's wet, and a lot of things that get lost is that contractors get to the end of the month, and if it's raining, as it most likely is in Melbourne, then or it's cold or something like that, and you've got a connection to make, and you've got to weld that connection. You can't do it. And so if it falls over into the next month, that means you don't get paid again till the following month after that. So, are you taking out bridging finance or extra finance to pay your people and to keep things going? Whereas for the sake of that, you can be doing this in any weather conditions. No issue whatsoever. Drop it in the mud, pick it up, give it a quick wash off and chuck it on the pipe. No issues. So it can be completed, signed off, tested, and you're in the money.
This is for a question. Do they test here as well as other countries, or is it all tested basically in the same place?
These fittings tested, you mean, at factories?
Well, you know how you're saying they go here, they go to other countries. We're obviously all different, soil grades, whatever, like you talked about before. When the testing happens, do they test here in Australia as well as other countries, or what do they do?
Well, the testing is based on the worst possible conditions. So, so it covers every condition there is. So high salinity in the soil, if you're close to the sea, for instance, like most of the coastal towns in Australia are close to the ocean. So generally, the closer you get, the higher the salinity in the water. And then obviously harsh conditions around temperature and flow and
so they create
movement.
They create that in testing facilities, and then.
And that goes through a NADA lab that wants to test for 100-year design life based on the worst conditions. So they cycle it.
So there's a hell of a lot in the background that happens before we even get to design.
And for us to redesign something, it's 2 to 3 years of R&D and testing before we're comfortable to release it to the market. So we don't just go, we want to copy that product, and we'll just get somebody over here to make that fitting and somebody to make that, and we'll put it together and we'll chuck it on a test, and then we'll deliver it to the market. We over test everything. This fitting, for instance, in a 100-year design life, the standard called for 24,000 cycles at the start and at the finish. So we increase that to 40,000 cycles.
Oh wow!
So everything we do is well above the norm for the market, to make sure that we have safety factors built in. And I'm not being rude when I say this, but there's always a contractor consideration that we take into account as well, in case somebody is having had a big night the night before, or they're not quite thinking about what they're doing on the day, or they're thinking about the footy they're going to that night or whatever, and they don't quite do up a bolt or something like that. We want to make sure that it's still going to pass. It's still going to meet the requirements. So we just want to take that extra step, like removing the need for torque wrenches on these, for instance. And this fitting can be reused, at least 40 times.
Oh, really?
So, if you want to use it for testing, for instance, you can take it off, put it on, take it off, put it on. Polyethylene manufacturers use it for testing poly when the poly comes off, and they're going to do their AS testing and things. So, so it's very versatile from that perspective. The bolts are heat bonded Molybond stainless steel 316 bolts. So what that means is that they don't have to wrap them either. Most councils have it in their spec that you've got to wrap, but if the wrapping doesn't quite work, you've got the extra protection.
Is that for corrosion? Or?
Yeah.
Okay.
And the Molybond's like an heated oil adhesion to the bolt to stop it from creating any kind of corrosion or anything else.
Fantastic.
So it's pretty bulletproof, honestly, as a
seems
fitting.
it.
And the areas for failure generally outside of our fittings is in this area here, because this takes the most stress. Because as you can imagine, when it goes under pressure, the poly wants to do this. So this is the smallest part, but has to be one of the strongest parts. And that's where the ductility of our metal comes into it. Is that it allows for that bit of extra flexibility. What we see failures happening is cracking here around the bolt heads where it just can't,
So similar to an engine.
handle. Yeah.
Okay.
We also have connectors. The connectors are expensive but very valuable in certain circumstances. So we would say if you had 3 connections to make in a 125 poly system or something, you would have 3 of those done by the time you got the welder set up. So then it's really beneficial. It's really worth spending the bit of extra money rather than looking at the cost of a connection or a flange or something like that. Look at the overall cost of how much it's going to cost you. You're going to be on site for maybe 4 hours.
You just wouldn't get the flange. It's just so much extra work.
So with these,
bother.
you're cleaning it up the same as if you were doing the fusion.
No.
You don't have to shaper and everything like that.
No, you just got to clean the edge off the pipe. Just give it a bit of a clean up on the outside. And then just install.
That brass tooth would just grab on.
Your favourite thing to do, sit there and have And look, you're not having to read through 2 pages of instructions on how to do an EF weld, for instance. And I've seen guys use the wipes to wipe
the
their
old
hands.
barcode. Scan the barcode.
I've seen guys use the wipes to wipe their hands because they think their hands have got to be clean
as well.
Or they tip the fitting out of the plastic bag and onto the ground. And as you know, you've got to cut one end open and slip it on, and then cut the other end open and put it on, and then take it off. So we're removing all of that risk, I guess. So if you don't want any risk in your business around installation and things like that, you want it to be easy, as far as time and any conditions, definitely this is the way to go.
Are your competitors copying you? Are they chasing you? Are they catching up?
There's copies of this out there,
but
that's all they'll ever be. They don't have the technology, they don't have the 100-year design life, they don't have the 10-year warranty that we have. So we have a full 10-year warranty on these as well. You're lucky if you'll get a year.
10 years is a long time. People don't think it is, but that's a long time, especially being in the ground. Under tension.
And we have so much confidence that that's why we offer that guarantee. It's different to a design life. Design life is something where if it's in the system, you should be able to repair that or replace parts on that product without having to remove it from the network. So that's the difference. The design life means everything stays as a system and should never have anything removed from it. So I mean, in a design life, if something happened to this bolt, for instance, you could just take that bolt out and put a new one in in the system without having to remove it. Same with the valves, you just take the bonnet off, replace any parts inside and put the bonnet back down again. So that's the big difference. In relation to a Haku, so a Haku is dedicated to polyethylene as well, same as these fittings here. And the big thing here is that you don't need to cut pipe to the right length to install a all flange ductile iron tee, which not only is very heavy, but it's time consuming. If you're adding a ductile iron hydrant tee, you're adding 3 leak points, as opposed to this one here, potentially 1 leak point with 1 flange. You can dry tap these or hot tap these. So you run out your 125 coil of pipe, and as you know, if you cut it, you quite often have pipe straighteners on there to stop the pipe from recoiling, which is dangerous. And so you run along, you mark it out where you want your hydrants or your air valves or anything like that. And then all you do is you just install it, and you can cut it with your standard poly cutter. Take the cassette out with you. And then it's around about, to install a hydrant, it's about 10 minutes. So put that on, quick. Drill it out, install the hydrant, 10 minutes.
Can I ask one question, and this doesn't have to be on camera? I've just looked, right? This has got rubber all the way around.
Yes.
That's got rubber. That's got rubber. Just any reason why this doesn't get rubber and it's only an O-ring?
Yeah, so there's rubber on the base. So the rubber on the base of the fittings, this is actually probably one of the strongest parts on the fitting. So friction coefficiency between any product and rubber, hence the reason we use lube to push things into rubber fittings and things, that stops it from twisting. So because with a hydrant tee, obviously you're not going to, if the guys come along with a fire engine, they open it up and they want to operate the hydrant, they don't want doing this.
No, absolutely.
So we hydraulic test these, twist test them to make sure they don't move. And this is a big part of that. But in relation to those fittings, the actual seal is built into the. It's moulded into this, just because of it being threaded, and because of the direction or the size of this. Trying to get an O-ring like this into a small fitting like this is quite difficult to get it to sit down properly.
And not move and not dislodge itself.
And this is, this O-ring is substantial, and it just squashes down onto the PE. The big advantage with these fittings here in particular is we make them long in the body, like this length and body, because with polyethylene you're going to get expansion and contraction. And you get what's called creep, obviously. With this fitting here, because it clamps, it's millimetre perfect to poly, like these all are here. The poly comes, the nature of the poly is it will come in, it will want to expand and contract, it's got nowhere to go. So the length of the body will stop it from moving, which means that it'll go in the opposite directions to where it came from. So if it hits a fixed point, it disappears and goes back in another direction. And the other reason for the length of the body is if you're taking a 100 mil, or I think it's 88 mil core out of a polyethylene 125 pipe, you're sort of taking quite a big chunk of that pipe out. So we just add the mechanical strength back in by the length of the body to make sure that it's still going to operate at the right strength.
And are these manufactured in Austria?
These are manufactured in Austria, yes. These are manufactured in Poland. And I'll go to our Sinoflex in a minute, which is manufactured in Czech Republic.
Any reason why they go to other countries?
Oh, we just have factories there that specialise in those products. Because of the tooling and everything else, you kind of have to funnel bulk products through a factory to make it viable. And if you have too many products and too many tool changes all the time, or you'd have to have a factory.
I just thought maybe there was more of a demand for something in those countries.
No, just because it makes sense to have those expertise in those different areas to make sure that it's consistent. The other big thing with a System 2000, just going back as well, is you'll see that the ring is it's a conical shape, so it's like a triangular shape. Most of our competitors that have copied our product they have a square ring. What happens is when the pressure comes on PE, is the first thing that happens is you get a bell that forms on the PE, because if pressure hits this, it swells, and then what happens is that it does that. With a conical ring, what happens is the pressure is less on the overall ring, and it lessens as it goes in, which means it releases the pipe.
Yep.
And then it forces in here and stops that pressure from happening. And when a PE bells like that, it quite often can start to split or create small leaks around that area. So that's why there's so many issues with compression fittings, small diameter compression fittings.
Yep.
If you have a look at small diameter compression fittings, you'll notice that there's like a little bell on the PE. That's always a point of weakness in the polyethylene and stuff as well. So we do these up to DN 630. You can see here in the larger diameters, that's a 450 that we have a hinged plate there just to make it lighter and easier to handle, so you can wrap it around.
Finally got some handles on something.
And these are body-to-body connection as well, so you don't need torque wrenches for these either.
Yep.
So because they're millimetre perfect, you just tighten until the bolts hit the body, and then it's
And does that have the little plastic in between as well? Or
No.
It just sits with washers?
just bolts and washers, which is fine, because it's not going through such a deep connection like it is here. So as thread and things. So these ones are our threaded connections. So and in the threaded connections we have a secondary seal in here as well. So when you're using your tape or thread tape, or if you're using thread paste or anything, if there's any issues, there's a secondary seal there to stop any kind of leakage as well. And these are all coated BSB as well, corrosion coated, so you don't end up with that different material creating corrosion. You don't end up with any kind of corrosion activity in there. Fully encapsulated to stop any movement. There's a lot of very narrow tapping bands on the market now, especially plastic ones, reinforced fibre plastic. The issue with those is that they're not designed really to deal with the forces of PE. And over time they do move, and then if you've got a small tapping saddle on something, and the pipe's doing this, and it's in the ground, or it's got a service valve on there, it's gonna just start moving this way. So this will go this way, the pipe will go this way, and then you'll have this hole that eventually it just starts to leak. So
what about this one? I was looking.
Oh yes, So
that's what I've been looking at.
So in Europe we do use these for PE, but in this part of the world we're not allowed to, because they want a positive fit, so they want the body-to-body connection. But for ductile iron, for AC or steel, we do these in a BSB version and a flange version as well. So if you're installing a hydrant, for instance, if there's a hydrant needed on a ductile iron system, you can use one of these for that. And it's fairly quick. It's just a stainless strap. You use a torque wrench for this one, and you torque it up, and then you can live tap it as well into the steel, concrete line steel, asbestos cement, whatever you need to add, either an air valve or a hydrant, or even a connection at some point. You might want a 100 mil connection coming off that. Same thing.
So just not PE for those ones.
Just not PE.
Just not here.
Just not in our part of the world. Okay. So we have our Sinoflex range. So Sinoflex is what's called a multi-range connector. So it connects various different pipes, pipe ODs and pipe materials together. So this is a DN 100 Sinoflex. So what that'll do, on the label here it says it'll do a pipe of a 104 OD to a 132 OD pipe. So you can have a 105 or a 106 pipe OD here, and out of this end you can have a larger diameter pipe coming out the other side. The reason we can do that is because we have this flexible ring in the system here. What that means is that you can, obviously different ODs, you're either tightening less or much more, and it's just creating a restraint connection for those two connections. So most commonly you might have PVC to PE or PE to ductile iron, for instance.
Yep.
And you need to make sure you have a restraint connection, but you also need something that can attach the two materials together, even though they have different ODs.
Yep.
What's different for us in relation to Sinoflex and multi-range connectors in the market, and what makes us a leader in the market, is that we have this connection here is flexible.
Yep.
This is patent to us. So this is patent to us. It houses our grippers. You can take that apart if you want.
On the side.
Yeah, I just want to show the inside of that. Look at that bad boy.
So you can see the grippers are integral to the plastic connection, which is flexible, and then we have rubber, which is also attached to the end of the ring. It also means that when you're tightening on any side, it comes in evenly. The advantage of that is that you don't need a stiffener inside plastic pipes.
Yep.
We're the only ones that have WASA appraisal and approval to have no stiffeners inside plastic pipes.
Okay. Yep.
And for the simple reason is, if you have a gripper here, and a gripper here, and you tighten, it changes the internal diameter of the pipe.
Yep.
So you need something to keep the wall round inside. That's why you need a stiffener. With this, it tightens evenly because it's flexible. As you tighten, it just tightens in evenly around the pipe and makes a connection that's safe. Again, they have a 10-year warranty on them. They are. We don't have a 100-year design life on these yet, but we are working toward that. And the little things like the bolts are reversible as well.
Okay.
So sometimes you might come up against like a head wall, for instance.
In the way,
you might have a head wall here, and you can't get a spanner or anything in there, so you just basically undo it, spin it around, and tighten from the inside rather than the outside, because this is a locking mechanism here to stop it from moving. And so that they're also Molybond coated bolts, 316 bolts. You get 4 degrees of deflection on either side. So if the pipe moves in one of these, you get a lot of movement. So without it creating a leak. It's fully restrained. You do need torque wrenches for these. But all the torque settings are written on the labels. And the other advantages are that we also do step versions of these. We do flange adapters. So this is a step version here. So this says it's a DN 100 by 80. So you've got 100 mil here, and 80 mil here, and then it gives you a label that tells you what sort of materials and what sort of size pipe that it can do. So
in terms of materials, it can go from, is anything it can't join onto?
Just things like concrete pipe, because it's
can't bite onto it.
Well, it's no, because it'll crush. Anything that's too solid as far as that sort of goes, it's no good on stainless steel and copper, because it's too slippery. And also quite thin-walled sometimes.
But in terms of like so for example, fire service, galvanized to then PE. You can use it as your adapter with that.
Absolutely. PE, PVC. It'll work on AC, but it's generally a case by case to see what the condition of the AC is like. If it's not in very good condition, then it does need assessing before being. You may not tighten all the way. You might just tighten enough to engage the gasket to form a seal, maybe. So it does PVC as well. Yes, it does. And we do. Because in some sizes, in PVC and PE, for instance, in the larger sizes, like a DN 200 PE, the PVC equivalent of the same ID might be 270. So we do a fitting that will take care of those two sizes as well in one fitting. So there's quite a big gap in some cases between on the reducing fittings. Another big advantage with this is that we have these end caps. So testing, gone are the days of using a plug, for instance, which is not all that safe. Quite often, you have nowhere to put either that or you're going to flange off the end and you're going to put a blank plate with an elbow on it and a gauge on it so you can see if your test is successful.
Yep.
You can, if you take a few of these, you can put them on any pipe material that you're testing. You can put a gauge in, that threaded gauge into here to make so that you can check your pressures and everything else. It's reusable over and over again.
Yep.
If there's any issue with the gasket, we can supply new gaskets, we can supply new gripper areas, so it's fully versatile from that perspective. But also with this one is the rider main. So, you know, at the moment you might get to the end of a line and you want to run a line off that for a subdivision or a couple of houses or something like that.
Yep.
And you might have a 65mm PE coming in. And generally now there might be an elbow on the end of a blank flange on the end or something like that.
Yep.
But you don't need that. You can put this on and you can run your 65mm threaded connection straight into this
off the roll. Yep.
and straight out into the properties and stuff. So, so again, it just removes that need for welding or using other parts such as end caps. Using flanges and things. Because once you weld something on the end of the line, and then they want to continue for the next stage of the subdivision, you've got to cut that off. Weld something to it or use a System 2000. Whereas with this you can take it off, you can carry on, and then you can use it again at the other end. You know? So it's just flexibility. And
one question I didn't ask before, and I apologise now that we're talking about different components. How come you guys don't go into smaller gate valves?
Oh, we do. We go down. So that's 100 there. We go down to 80. We do 50mm as
so
well.
You're not, so you're not in like the minor domestic market of 20mm and things like that.
Not
just
generally.
Staying away from that.
Well, generally because it's just the cheap and cheerful type end of the market, and we don't compete in those areas because generally they're using brass or something like that. Which is, we're never going to compete in a fitting like this. It wouldn't be cost effective.
Makes plenty of sense.
We do, however, we are supplying now black POM. POM is this plastic material, extremely strong and durable. We're making those in our factories as service valves and plastic. So, and they're a very, very good product. You can adjust the size of the connection. You just screw in a different connection and it'll do different size pipe as well. So,
fantastic.
But so we manufacture 90% of what goes into our fittings. Pretty much everything. These are done by us. The rubbers generally done by us. So everything we do, we try and take control of as much as possible. We have a fully auditable trail of all of our material certs for everything. Coating, we get audited regularly on our coating processes, so and that's part of having the GSK approval on our products, and we also obviously we have all the necessary requirements around, SMK certs. On our valves, all have watermark. They're all lead free now as well, lead free watermark, which is a requirement. The other products don't have any metallic parts touching water or anything. It's all just rubber, so there's no lead issue there. But in relation to valves and things, we have no lead in our products whatsoever. So,
in terms of these fittings, for example, I haven't seen any tabs. So does that mean they're a slip socket? So for example, if you've cut it and you've got to join it on.
Yes. It can be a slip coupler. You can slip it on, pull it back. So you can, if you've got a nighttime job to do, for instance, you can pre-assemble at night, during the day, get it ready, lower it in, pull it back, tighten it up, and test, and you're out of there. And it's the same with the System 2000. That has a ring on the inside for insertion depth. But you can take that ring out and you can slide that on as well.
That's even better.
The difference is System 2000's for virgin PE because it's round and it hasn't changed shape, and because it's millimetre perfect, you'd have a trouble getting it onto a piece of old pipe. Whereas this is going to give you the comfort of being able to just get it on there and not have the issues of trying to force it on or do any of those kind of things.
Oh, we used to do. There was a job in Cheltenham that the fire service used to go all the time. and we'd have to cut into it, and then we'd jump it onto old gal trying to change it to PE. It was an absolute nightmare.
Exactly.
Whereas if we had been using those, it made life a lot easier.
In the System 2000, we do bends and tees and stuff as well.
Okay.
So if you're in a commercial building, you're doing a commercial layout for the water to get to the fire service and to the property itself, then as you know, most plumbers like a push and play thing rather than a weld thing. So, and it's a lot quicker with this in those smaller commercial applications as well, because you've just got everything there. You don't need any special tools. You're in the ground, you're connecting, you're tightening up bolts, and you're ready to test, and it's just super quick.
So and easy enough to witness mark and everything like that as well. Not a hard thing.
Okay, so we move on to our Ozcan product range, which is out of Turkey at our factory in Izmir. During COVID, we were building a new factory in Izmir, which is the most technologically advanced valve factory in the world now. It took a lot of investment, well over 100 million euros from Hawle. It now looks like our Hawle business, and sort of as part of our strategy as a business, clean, quality, high performance manufacturing. We have a lot of large lathes and things, a lot of large machining equipment. We've got sandblasters that'll do a 3.2 metre butterfly valve, for instance, which would be the height of the ceiling here by the time you add everything on. This is a small check valve in the scheme of things. We're regularly doing 1200s, 1400 diameter, which are, are very big. So we do seal on disc butterfly valves, double flange, double eccentric seal on disc butterfly valves. Why that's important is that, and why the material, and we talked about before with those valves around the 400 material, is that we're one of a few that can weld a stainless steel seat to our valve. So in this one here, you can see there's a stainless steel seat on the inside. Because of the material, you can actually weld stainless steel to ductile iron. We have robotic welders that weld that to the seat. Then we coat the entire valve with the coating, and then we micro finish the stainless steel seat back to how it is. The reason why that's important is because if you're painting up to a seat, you're always going to have voids. So we always want to paint, let it go off, and then micro finish back so that you don't end up with any voids. You only need one little grain of sand or silt to get in behind that, and it'll just destroy the valve in no time at all. This is a tilting disc check valve, but a butterfly valve. It looks very similar. Operates in a slightly different manner, and it's a double eccentric, which means that the disc is pulled up and pulled back, so that when it's operating, it doesn't come in contact with the seals. So, because a lot of single centric valves, which are rubber lined, what happens is the disc is always rubbing on the rubber, and especially where the spindles are on either side and inside, it rubs on the rubber, and what happens is eventually the rubber just starts to wear away, and it also, because rubber has a memory, it'll stay that way, and it'll form a leak out through that point. With our butterfly valves, they're leak proof in both directions, so we test them in both directions for pressure to make sure they're strong enough to deal with bidirectional flow. Like I say, they're double eccentric. We use duplex stainless steel spindles again. And again, the torques are very low on our valves. We don't use threaded connections inside for connecting spindles back together. We use what's called a Pratt & Whitney key, which is a hydraulically pressed stainless steel between the two stems when they come together with a pin. But just done cold with a compression. And so
it's under it's pressure.
Yes, exactly. A hydraulic pressure. And these screws here hold hold the ring in place. They're the only place that we have threaded connections. And the reason for that is if you add threads to a valve that's going to have silt or any kind of stuff coming through it, it's going to get into the thread.
It's going to hold that.
If it gets into the thread, it's going to actually corrode the valve. With a stainless steel welded seat, it's also cavitation resistant. It removes the need for a lot of them have a pressed-in seat. Pressed-in seat can be damaged by cavitation. I'll tell you that's a good thing, because then if it's damaged, it can be replaced. But I don't know if you've ever tried putting something back together that you've taken apart that came factory assembled. It never goes back together the way it was.
No.
So
Us with cars.
Yeah, exactly.
Well, I've got all these extra nuts and bolts. And our butterfly valves are the same. The seal is actually up in the top here. So you just remove this. Take the seal off and put a new seal on if it gets damaged. If it's big enough, you can do your isolations and somebody can get inside the pipeline and they can
you'd be able to fit in that.
Yeah, you'd be able to fit inside. You'd be able to undo that inside the pipeline, replace and put it back on. If it's only a small valve, it's only a matter of moving it out. Taking the half an hour it takes to take those out and retorque all the screws and put one in. And pop it back in. You don't have to take it away and press out any rubber seats. Things like wafer and lug butterfly valves or rubber line butterfly valves generally are throwaway items once they start leaking, because the hassle of trying to actually get the disc out and actually get the rubber out and then trying to get another one in is just huge.
Installing this, you don't want to be taking it.
No, exactly. So, we do butterfly valves up to 3.2 metres in diameter.
3.2 metres in diameter.
3.2 metres in diameter, PN10 to PN40 in pressure, tilting disc check valves, up to sort of 1.5 metres and up to PN25 pressure. We also do a slanted seat check valve. We do needle valves. Needle valve is a valve. Some people call them a pig valve because they look like a pig body. The purpose of those is high flow and high pressures to low flow, low pressure without causing cavitation. So it basically, the water comes in, goes around the piston on the internal part of the body, creates this cavitation. Then on the way out, we have a cavitation basket that directs the flow with
like a baffle.
It breaks up the cavitation, but also positions it into the centre of the pipeline rather than out to the walls of the pipeline. Because as you know, bubbles will just destroy anything, like water blasting something. So that's a crude way of explaining that without sort of going into it too much detail. It basically has a centre piston body that sits on bronze guides. And it's just operated back and forth depending on the distance, how much flow you want out, and pressure and things like that downstream. So we also do air valves and our foot valves and inline silent check valves, which are valves that don't have any external parts like these do, and it basically runs off a spring. So spring to close, pressure to open. So, if you need it to close quickly, the spring will just slam it shut. Well, it won't slam, it'll close, and then the last sort of 5% it slows down so you don't get any slamming. And that's a buried application, so in line in a pipeline, so it just operates as and when required. If the pressure comes off, it closes quickly with the spring. And as the pressure comes on, it just forces it open again to run it. So
really intricate technology, really. You wouldn't think to need all that.
No, but it's definitely a requirement, especially in the larger diameters and things, to protect things like pumps and things like that as well. So then we've got our Nova Soria fitting, which is out of our Italian factory. So Nova Soria is about, I think I might be wrong, but 94 years old now. 97 years old. And They're still 40% owned by the Ferrero family, and 60% owned by Hawle. So it's a joint venture as such. It's been very successful because of our investment in things as well, and their technology and their quality manufacturing. Everything's made from carbon steel. And it's coated in real sand nylon 11, it's called. It's the only plant-based coating, so it's completely organic.
The other...
That's not organic, no. It's but in comparison, they're both very, very good coatings. The best coatings, actually. And this one here you'll be able to leave this outside in the sun, and it won't. Like the blue ones will go like a powdery white colour because they oxidise. These are designed to go above ground as well because of the black oxide. They deal with the UV. They have a larger temperature range from cool to hot, so around 70 degrees and down to around 0. Whereas these ones here, they top out at about 40 degrees, and then they start the coating. The coating gets soft. That's all. So so they're for standard water network. This is for sort of lots of different applications. So we make these. We weld them, we roll them, we shape them. Nova 3 is known as the tailors of the steel connection industry. So unlike a ductile iron fitting, which is cast out of molten metal, these are made from plate, steel plate. And we've made fittings, non-restraint fittings for a nuclear power plant in Turkey some 5 or 6 years ago, 4 metres in diameter, and 2 5-metre flange adapters. So you can imagine the size of those.
Are you guys big in mining?
We're sort of getting there. This is a target for us in the future, for sure. But our advantage is that we can make anything. So if you say to us, I want a connection, this is something we do regularly, is a connection from concrete to PE. We'll make a non-restraint concrete side, reducing down to the PE with a restraint connection on the PE. We can weld wheat flanges on it so that you can concrete block the concrete side to stop it moving, or we can put threaded rod connections back to a head wall to give it restraint. We've done all sorts of unusual eccentric reducers. So, flat bottom reducers so that you don't get any flow issues, especially with sewer. You often want a Y coming into a connection or something so you don't disrupt the hydraulics on a system. We've got a fitting here that is for pipe repair, so cure in place pipe, GRP pipe, so when they need to repair a steel pipe or an asbestos pipe, and they're running in the inside the pipe, they're running in the liner, and then they're expanding to the external wall of the pipe. The issue they have is when you get to the end of the fitting, you've got to make a connection inside to seal off that, so you don't get any water between the host pipe and the new connection, GRP connection. So we make these barreled fittings here longer so that they can add that inside and then make a connection back to the host pipe. So you get a nice connection whether it's restraint or non-restraint, and you get a rubber that seals around the pipe so you don't get any water inside the connection. And then at that end they can do their termination and make another connection leading off from that as well in one steel connection. And we reduce in this area here because from the host pipe it'll drop down to the liner. And so you need this part to be the same ID as the host pipe. But you need that end to be the OD of the host pipe. So because if you have too big a step, it weakens the connection and it doesn't really work that well. So we do flange adapters, we do T's, we do multiple connections. So these are restraint connections, these ones. So like a standard gib bolt, you have bolts running along the longitudinal part of the body. They always get tightened first, and then these get tightened down onto the pipe material. The big difference between these and our restraint connections in Hawle is that we have to have a liner inside plastic pipes because, like I explained before, these are all individual grippers.
Yep.
So if you tighten those down onto a plastic pipe, the pipe inside will just change shape. So you need something to keep it nice and round. The big difference for us is that our liners are unique to us and they're patented by us, and that is that they're an expandable steel liner. They go inside in a smaller diameter. They have bolts on them that get expanded out to the internal wall of the pipe, and then those bolts are removed, so you've got a completely flat surface. And then you can install these. The liner prevents any kind of vacuum from sucking the fitting in and releasing the grippers. Removes any issues around restraint from the pipe changing shape or anything else. And with restraint connections or any connection under full pressure, that's when the fitting's at its strongest connection, because all the forces are pulling out. When that pressure comes off and you end up at a zero pressure situation, you end up with vacuum. So it wants to suck in, and then it wants to release from this. And then if they put it under pressure again, it's quite likely going to blow off. With a liner in these kind of positions, it allows you to make that connection and not have that issue. Sinoflex is good because it's flexible. So it'll grip on. If there's any movement internally with the pipe, it'll change shape with the pipe as well. So you don't have that issue with it letting go. We make these in Italy. Hygrade stock these. A lot of these fittings up to about 750 in diameter. But one of our biggest strengths is making specials in about 18 working days. And then they can be shipped here. So I think the industry standard for steel fittings is about 24 to 28 weeks in Australia for manufacturing. We can have these made, any specials you want, and delivered here in 12 to 14. So, and that's sea freight. We regularly air freight in fittings. We have encapsulation collars. So we don't have one here to show you, I'll get a photo up on it and show the camera. So this is a repair methodology under pressure repair system for all pipe materials. So if there's a leak on we were talking about electrofusion earlier on. So just to run through, is that okay? Is that we have a bottom shell and a top shell. They get connected with the bolts here. And then we have a rubber that gets reattached together, glued back together and pushed into the body. And then we have end caps, steel end caps that get bolted together, and then it performs as a gearbolt would. They're bolted back together here, all torqued up on the sides and on the ends, and then it's fully completed leak protection. This is a permanent repair. It's not like a clamp that goes over a leak that will last maybe, if you're lucky, 10 years. And then we end up putting these fittings over the top of those because they start leaking. So this is a permanent repair made of steel that has a top connection and a bottom connection, which get removed at the start. The reason for that is that the bottom connection allows the flow to change to allow you to come out the bottom. You can take it away with a hose or something like that, and then you can work on the fitting easier. You still have pressure there, but it's easier to work on. And then when it's completed, you put the bottom connection in, and as the body fills up with the medium up through here and comes out through the top connection, then you seal the top, just to remove any air from the fitting. So the only thing that will destroy these fittings is air trapped inside, like anything. Air is, as it compresses, it just wants to get out, so it just gets forced out.
How are they?
We're thinking the same thing.
How are these stuck on?
So they're threaded internally here, and then that's threaded into it, and then that taps down.
That's tapped through that.
And that's so the idea is you tighten those individually, or just as you require.
There's a process for crisscrossing them. And,
removing a wheel.
Yeah, and there's not a huge amount of movement needed to engage the grippers. So it looks like a lot, but there's actually only sort of 1.5 to 2 turns to do to grip it.
Oh, okay, so it's not like, you're not cranking it down 50 mil to get it in.
No,
Yeah, because I'm going, because imagine you're going and trying to line them all.
See installation videos on the process for these.
Okay, yep.
And the thing with the grippers here is that depending how we work it is that depending on the pressure of the system and the size, the DN size of the pipe, depends on how many grippers you have. So if this was a PN25 fitting, for instance, and it was say DN 600 or 700, you might have 2 rows of grippers.
Okay.
Because each one of these grippers carries its own Newton meter force as far as restraint goes. So then what we do is we know how much one will hold. So we look at the Newton meter forces required to restrain that connection, and then we look at how many grippers we need around that pipe. It doesn't damage the pipe. It works off friction rather than biting. It bites into the pipe, but not so deep that it would damage the pipe. It's like a peel on a PE pipe. You know, if you were to peel PE, that's kind of ingress you get into the pipe. And it's worth spending the time, because what you end up with is a fitting that'll last you 100 years. So never need to be replaced. In our duo fits, I mean, we can do the under pressure repair systems, which is a similar concept to a C-Quick, which I'll show you in a minute, but in a smaller diameter. We can do up to PN 80 in pressure. With the longest one we've done is 5 meters, and I think the 3 meter in diameter. So they've been and I don't know if
slightly.
That's huge.
I don't know if you've ever been to Venice in Italy, but you know the waterway, the lagoons and the canals. So there's some of our duo fits installed under there. So somebody used an anchor one day and pulled up a water line. So the divers took one of our fittings down, which was 5 meters long. They took it down and they installed it underwater and fixed a leak. So, and because originally these were all built for subsea applications. So every one of our fittings can be taken and put in the sea. You just got to change out the bolts and things like that to a more suitable corrosion resistant application. But the big job we did in Turkey, a lot of that was ocean outfall, so it was on GRP. And the advantage is that we have a 30 millimeter tolerance in these. And in our non-restraint, we have 30 mil tolerance, plus we also have a 3 degree plus and minus deflection. So if you're using GRP and it deflects a lot, it wants to crack. So our fittings get used a lot for that as well.
Mark, what have we got here?
So this is a C-Quick encapsulation collar. So this is for repairing of small diameter pipelines under pressure. Like our Duo Fit from Nova Ceria in the larger diameters and the larger pressures. Duo Fit has more flexibility around the size of the pipeline, OD, and the size of the fitting that we can make the centre section go over, because they're made to order in a lot of cases. With the C-Quick, how it works is that this is they're dedicated ductile iron rather than carbon steel, and they're made in specific sizes to cover specific pipeline DNs and internal cavity spaces to cover couplers, flanges, connections, etc., or just flat pipe. If it's got or round pipe without any connection, if it's got a split in it or something like that. How it works is that there's a rubber that goes over the pipe here. That's put over, it's split, and then it's connected back together. And it's connected in line with this body position here. So that just slots into there as it does over the pipe, and then the two shells are pulled together. It comes with a gasket that's already pre-assembled. And then the two halves just basically come together. The idea with the connections here is that you remove these connections the same way you would with the duo fit, just to remove any air from the fitting.
Yeah.
So as you install it, you're tightening it up over the gasket material until it engages the gaskets on the sides here, and then you just, once it's filled up with water or something, then you just tighten up that dot connection and just removes all the air from the fitting. So I mean, it's designed for smaller diameter pipe work, especially prevalent for old cast iron, where you've got a socket connection on cast iron, for instance. Because these days with cast iron being older, it's sort of, as you move it, you get that any kind of movement, you get a leak often in the connection area. So somebody's building a subdivision over here, and there's a lot of earthwork going on, and there's a lot of vibration. Quite often, what will happen is that at that connection there, there'll be a leak come through. Why it's important to use an encapsulation collar, regardless whether it's this one or a Nova Seria one, is because it's not so much about whether you can switch the water off or not. It's how people are affected by that being off. But what it is when you put it back on under pressure again, is you end up with other issues. So especially in an older network, or if there's older valves in the network or something like that, as soon as you put that back under pressure again, you get that thrust of water. And that thrust of water, it will pick up any weak connections, weak valves, or anything like that in the system, and create another leak. So it's better to fix it under pressure or reduce pressure rather than removing the pressure completely, because it can cause other problems. And this is the brochure here for the fitting, which shows it going over the pipework. And it's a very simple fitting. It's a lot cheaper than a duo fit, because a duo fit is designed for larger diameters. So
what's the minimum diameter you've got of these?
80 mil. So in a DN 80, for instance, it'll do a range of 83 to 100 millimeters in pipe. So because the DN obviously on metallic pipes and things, and PVC is ID. PE obviously in a DN is OD. So it's the only pipe material out of all the pipes that has a DN that's OD. We're pretty smart like that, eh?
What kind of size have we got behind you?
So this is a 300. So if we look on the brochure here, so 12-inch DN 300, we'll do a size 320 to 340. And the encapsulation cavity ID is 530. So inside here you can have like an electrofusion coupler, for instance. Or a ductile iron socket spigot connection, cast iron socket spigot connection will fit inside this internal cavity here in length, and so it also has a length on here of 500 millimeters in length on the ID side. So from sort of here to here type thing is 500, and then you've got this 530 as the ID of the.
When you purchase these come with nuts, bolts, washers. All included.
Everything ready to go.
You're not worried about, I haven't got this or I haven't got that. It's all there.
All there.
Okay, fantastic.
And that's probably a half an hour installation.
At
most.
Very quick, very easy, robust ductile iron to keep the price reasonable, and it's a much smarter way of repairing rather than switching water off. Trying to weld, or
you're not taking anything apart, are you?
No, that's right.
Going over the top.
Burying for 100 years.
Then councils and stuff aren't ending up with annoyed customers because they've got no water, and any commercial applications too. Where there might be a manufacturing plant, they need the water to be running all the time to cool machinery and things like that. So there's so many reasons why you should just do everything under pressure. It just makes sense.
So in terms of that being under pressure, obviously this is the drain point, for example. So whilst you're setting it up, it's just draining the whole time as well.
So the bottom connection is generally this one here. So it doesn't drain, because in the smaller diameter the pressure isn't as great. There's not such a big volume of water. This one here you would keep open so that the water coming out the top, you're going to remove the air basically. If you try and force it over and you don't get rid of that air, then you're going to end up with it creating issues for the fitting splitting or something like that. So from the air pressure. So then you just pop that in once the water comes out through the top. If they're repairing something that is hasn't started leaking yet, but is close to leaking, and it's like a preventative measure, they can remove that and just fill it with water until it comes out the top, and then just put the bung back in. And that way, when it does fail, it's already
like purging a pump.
Yes, exactly. Yep, exactly. So that's it.
Beautiful.
Thank you.
Really appreciate it.
Thank you.
Thank you, guys. Thanks for your time.
Thanks, David.